The next subtopic we are going to learn is 9.2 Photoelectric Effect. So previously in 9.1 I have mentioned that light behave as wave and also as particle. So this statement here, the first statement, light behave as wave, we have learned in chapter 8 di mana Huygens principle and also double slit experiment have already proven that light behave as wave. Now we want to see, okay, whether is it true that light behave as particle. So there is one experiment, we call that experiment as photoelectric effect, to prove that light also behave as particle. Okay, so the experiment is, we have metal, so this one adalah surface of the metal, and we know that inside the metal there are free electrons. Okay, so the experiment, okay, we have lights shining through the surface of the metal, and then what we see is there is electron release. So there is an electron release from the surface of the metal. So this electron release, we call that as photoelectron. So why does this happen? Kenapa benda ni berlaku is because, okay, we know that lights, okay, they come in discrete packets, right? Discrete packets, so ni adalah packet. And then these discrete packets, we call them as photons. And then we know lights, they bring energy, they have energy. So this energy from the light, from the photons, is being observed by the electron here. So one photon will, okay, one energy from one photon will be observed by one electron. So satu photon dia akan observe, dia akan bagi energi kepada satu elektron, dan this electron akan terkeluar daripada metal. So as you can see here, we have, okay, let's say that we have 5 photons. So 5 photons, meaning that there will be 5 electrons released from the metal. So this only happen if, okay, kalau tengok dekat sini definition, the emission of electrons from a metal surface when EM radiation of higher frequency. So benda ni akan berlaku, okay, emission of electron ni akan berlaku kalau, okay, these photons have higher frequency. Kalau dia ada lower frequency, dia tidak akan dapat keluarkan elektron ni daripada metal. Must be higher frequency. So kalau higher frequency, meaning that, so we have learned that energy is equal to HF, Planck constant, times with the frequency. So frequency higher, energy pun higher. So meaning that these photons must have higher energy. Okay, if the energy is higher, electron will be released. So this released electron is known as photoelectron. Okay, so this one, there must be a condition. So kita tengok dekat sini, Einstein photoelectric equation. So the first condition is the energy from the photon must be higher than the minimum energy of the electron. So here, W naught ni kita panggil sebagai work function. Okay, work function ni adalah minimum energy yang diperlukan untuk release the electron inside the metal. So kalau energi daripada photon lebih besar daripada minimum energy dekat dalam ni, okay, electron will be released. So kalau electron release, meaning that, okay, it will be moving with a certain velocity. So if there's a velocity, there's a kinetic energy. So there will be a Kmax, which is maximum kinetic energy. So the second condition is when the energy from the photon is equal to the work function. So kalau sama, electron still akan terkeluar, but electron ni velocity dia sama dengan kosong. So dia akan release from the surface, but dia akan stay dekat sini, which means velocity sama dengan kosong. So Kmax, maximum kinetic energy, pun akan sama dengan kosong. And then last one, if we have energy which is less than the minimum energy, so what happen is there will be no electron release. No electron will be released. So these three are the conditions. So untuk kita keluarkan electron daripada metal, energy must be higher or equal to the minimum energy. Okay, so Einstein photoelectric equation ni dia cakap macam ni. It's based on the conservation of energy. So remember before this, okay, we have learned conservation of energy di mana energy cannot be created or destroyed. It can only be transferred. So kalau dia transfer maksudnya before and after dia energy ni must be the same. Apa maksud before and after? So we just assume this phenomena, this what happened here is as a collision. Sebab ni adalah particle kan, particle they collides with the particle dekat sini. So we just assume this one as a collision. So before and after collision, energy must remain the same. Itu adalah conservation of energy. So before the collision, we only have one energy here, which is from the photons, E. And then after the collision, energy yang terlibat adalah energy dekat sini, which is the minimum energy, plus with the kinetic energy. So E will be equal to minimum energy, which is the work function, tambah dengan kinetic energy. So if we rearrange this equation, we will get what we call as Einstein equation. Kmax is equal to E minus work function, di mana Kmax adalah sama dengan 1/2 mv max square equal to E adalah sama dengan hf minus dengan work function adalah sama dengan hf naught. So these are the formula that is given in the list of formula. Okay, so kita tengok work function and also f naught dekat sini. Okay, so work function as I've said before adalah minimum energy required to emit an electron or to release an electron. To release an electron. Di mana work function adalah sama dengan h still is the Planck constant, and then f naught ni adalah threshold frequency, which is this one. So threshold frequency adalah defined as minimum frequency to release an electron, where f naught is equal to c, speed of light, divided by lambda naught. Lambda naught ni adalah threshold wavelength. Okay, just ingat that one. So this one I think is given. Is it given? Okay, this one is not given in the list of formula, but this one is given. And then last one, we have stopping potential, which is defined as the minimum value of negative voltage when there are no photoelectrons reaching the anode. So stopping potential ni kita akan tengok dekat eksperimen. So basically this one is the setup experiment of the photoelectric effect, di mana kita ada battery, rheostat, voltmeter, galvanometer, and there is a glass here, di mana dekat dalam glass ni akan ada dua plate. We have cathode and anode. So cahaya akan datang sampailah ke permukaan metal cathode ni, and then electron akan terkeluar daripada cathode ni. Okay, but initially eksperimen tu untuk dia buktikan bahawa ada electron that flows throughout the circuit, dia tidak letak dahulu power supply. Because if we have power supply, obviously there is electron lah. So dia tidak connect dahulu dengan power supply untuk membuktikan akan ada electron daripada this metal. So apabila dia dapat buktikan, because untuk buktikan ada electron flowing through the circuit, this galvanometer and voltmeter akan ada bacaan lah, akan ada reading. And then after that, because we know that electron ni, electron has kinetic energy. So we want to measure this kinetic energy. So because we want to measure that kinetic energy, we connect with the battery. Okay, so to measure the kinetic energy, the battery, the voltage from the battery will be reversed. Dia akan di-reversekan. Okay, dia akan reverse dan di-increase until no electron reach other plate. So this voltage, we call this as the stopping voltage, which is Vs. The stopping voltage, which is the minimum value of negative voltage when there are no photoelectrons reaching the anode. That's why kita akan gunakan dekat dalam formula di mana Kmax, maximum kinetic energy, will be equal to the number of electron times with the stopping potential, which is stopping voltage. This one. We are going to use this formula as well. And then we see here, this is the graph of the photoelectric effect, where before we reverse the terminal, okay, the voltage will keep on increasing, but current akan sentiasa sama lah, but voltage keep on increasing. And then after reversing the terminal, voltage will be decrease, and also current pun akan decrease, di mana kalau current decrease, maksudnya electron pun akan decrease. Okay, so that one. And then last one, this graph of kinetic energy against the frequency. So we have kinetic energy against the frequency dekat sini. So here, initially, because if we have lower frequency, dekat sini kan, daripada sini start daripada kosong, and then lower frequency, and then electron tu tidak akan dapat keluar kan kalau lower frequency. Tapi kalau dia higher frequency, electron akan dapat keluar. So apabila electron tu keluar, akan ada kinetic energy. That's why graf ni daripada kosong macam ni, dia akan stay dulu kosong sampailah Kmax ni dia keep on increasing. So value dekat sini ni, okay, value dekat sini we call this as threshold frequency, which is the minimum value of frequency untuk kita keluarkan elektron daripada metal. So maksudnya kalau kita buat macam ni kan, if we sambung the straight line to the here, this one will be the work function. This one will be the work function. Okay, so since we have a graph of straight line, which means y is equal to mx plus c, di mana y adalah Kmax, and then m, the gradient is basically the Planck constant, and then x dekat sini adalah the frequency, plus with c adalah the intercept, which is this one, work function. So this one adalah the so this one work function dia adalah negative kan, sebab dia dekat bawah. So basically this is the Einstein equation that I have already explained before. So from here, if the Kmax is kosong, kinetic energy sama dengan kosong. This one adalah sama dengan kosong, bermaksud HF is equal to work function, di mana work function adalah HF0 kan. So HF will be equal to HF0, di mana this one you just cancel. So means F is equal to F0. The frequency will be equal to the threshold frequency. This one only if Kmax is kosong, which is this one here. Okay, during this situation, maksudnya elektron akan terkeluar tapi dia akan stay. So dekat sini F akan sama dengan F0. Okay, so I think that's all for the 9.2. Okay, kita akan tengok example in the next video. Okay, thank you.